London dispersion forces. What is it? The London dispersion force, also known as the van der Waals force, is the weakest intermolecular force. The London dispersion force occurs in both polar and nonpolar molecules, and is a temporary attractive force that results when the electrons in two adjacent atoms or molecules are in positions that makes the atoms or molecules form temporary dipoles. Temporary dipoles are a momentary attractive force between two atoms due to an imbalance of electrons between them. How can the distribution of electrons be imbalanced? Well, electrons move sporadically or unpredictably, and this sudden change in position could affect the attraction between the atoms. The imbalance in nonpolar molecules will allow for the dipole to induce another molecule to create a dipole, which creates a bond. Now, this is a London dispersion forces diagram, and on the left it shows the symmetrical distribution within the atom itself, and that allows for a nonpolar atom, and also on the right it shows the unsymmetrical distribution, which creates temporary dipoles. And an example of the London dispersion force is that London dispersion forces are the intermolecular forces that keeps the molecules in the liquid and solid state. And this is a phase diagram showing the solid, liquid, and gaseous phase. And it shows that the forces keeping these phases together are the intermolecular forces known as LDFs, or London dispersion forces. And factors that influence the strength of the London dispersion force. London dispersion forces vary on several factors. First is surface area. The larger the surface area, the greater the force due to the valence electrons being further away. Weight. The heavier the molecular weight, the greater the force is, which is comparable to the increase in boiling point as a molecule gets heavier. Molecular shape. The shape of the molecular structure allows for effective contact between molecules. The force would be greater. Polarizability. The greater the polarizability, the greater the force, since a greater polarizability tends to mean that the molecule is bigger and has further valence electrons. In conclusion, London dispersion forces are the smallest intermolecular forces between all molecules, nonpolar or polar. London dispersion forces allow for the solid and liquid phase to remain stable, and the four factors that influence the strength of this intermolecular forces are polarizability, molecular weight, molecular shape, and surface area. Thank you.